Good afternoon. This talk is about malicious PowerShell payloads versus deep visibility, and really looking at the awesomeness of PowerShell visibility and logging and what that means in the world of security. So my name is Daniel Bohannon. I am a principal applied security researcher at FireEye, which basically means I get to research the world's best hackers, learn what they do, the tools that they use, the techniques they pull out, and then we get to basically research ways how to better detect them. And so if you know me, you know that I'm obsessed with PowerShell. I'm obsessed with obfuscation, evasion, and different ways of detecting evilness. This talk, we'll jump into a quick introduction about PowerShell and in the security world, and then we're going to kind of look at like a buffet of in the wild examples of PowerShell, and then we'll dive into some forensic artifacts and a few different detection approaches that we take on a daily basis, and then we're going to dive into the awesomeness of PowerShell logging. And then finally cover some more novel detection approaches and end with some key takeaways in time for perhaps a few questions. So first, the introduction. I've been in IT for 9 years now. The past 6 or 7 have been in security. 2 things remain the same for me. I have an obsession with coffee and have always been an aspiring PowerShell aficionado. I got into PowerShell to automate my tasks as a server DB admin, and then realized that attackers also love PowerShell. And so it really got me interested in learning how do they use PowerShell, and then how can we detect their use of PowerShell? Because there's a lot of native open source tradecraft that attackers get to use, and we get to see that all day, every day. And then the ones that pull out some custom malware are really special because it's something new and something shiny for us. And so, as I said before, our team's responsible for studying this, for studying different attackers all around the world, seeing what kind of tradecraft they use, what kind of evasion techniques they use, and then how can we best detect their activity to protect our clients, our customers, and then to inform the broader DFIR defense community to better protect all of our own organizations as well. So when we look at these samples, we're going to start with some really unsophisticated samples. There's a huge range when it comes to the interesting level and the sophistication of attacks. And it all comes down to the fact that some people write better code than others, let's say, and some people use code they wrote 10 years ago, and they're better at coding now. But you know what? The payload from 10 years ago still works. And if it still works, attackers are going to keep using it because attackers will follow the path of least resistance. So why spend a whole lot of dev cycles to create something new when the old thing still works? So again, we're going to cover a whole different range of sophistication levels, and then we'll look at some different detection techniques and 2 awesome resources to start if you're interested in PowerShell logging and how it's really applicable to security. One is my colleague Matt Dunwoody wrote this greater visibility through PowerShell logging, and then the second one is PowerShell Hearts the Blue Team, which is an ongoing white paper blog post saga from Microsoft about the awesome preventative and detection visibility advances in PowerShell, which is an awesome ongoing read. So I definitely recommend you check that out if you haven't. So let's strap in. We're going to go for a little ride along, except instead of cruising streets, we're going to be cruising code and see what attackers are doing on the daily and how we can better detect that activity. So let the buffet begin. The first one, I'm going to start with the most unsophisticated, uninteresting use of PowerShell, I promise you. And it's interesting because there's a whole lot of reports out there talking about the insane levels of a rise of PowerShell attacks. And you have to stop and kind of look at those numbers to say, well, how integral was PowerShell in that attack? Because what we see people do is just use PowerShell as a glorified curl and just download a binary. And that's not really a PowerShell problem. That's a problem of your HR user enabling macros and running any arbitrary code, and the attacker just happened to choose PowerShell to download an executable, right? So when we see those kinds of reports, we want to always take it with a grain of salt and see, is PowerShell really the problem here? Usually the answer is no. It's just a matter of people running arbitrary code on their system, and PowerShell just happened to be the curl of choice. So this code right here, a small function that'll download a file to disk. In this case, it's a temp 5130.exe. And there's an array here that has a couple different domains. It will go through and try each of those domains until it successfully downloads from one, and then it will start process to execute that binary. Now, attackers don't write their code this nice. It usually is a little more jumbled like this. You might throw some inline comments in there to kind of mess with you. And this works for a long time. But when AV, when EDR, when Defender starts to detect this simple syntax, attackers will just wrap it in a few layers of obfuscation. So maybe they'll gzip compress and then base64 encode it. In base64 encoding it so you don't lose these special characters when they gzip it, and it becomes easier to transfer it from payload to payload. And then what we actually see being run is something like this, where you have the original payload in the dark gray, and then the yellow is base64 decoding that. And then you have a deflate stream stored in the variable s, which then is later decompressed and then piped, or not piped, but then executed by IEX, and then the payload is run. So in this example, this whole portion is what we would see on the command line, right? But the underlying code, if we're defenders, we can take this sample and we can do all this unwrapping manually, right? Base64 decode, decompress, and that's nice, and we definitely do that. But if PowerShell logging is enabled on the system, then every layer of this execution is actually logged, and we'll look at that in some later examples. Second example, PowerShell in your environment, looking at how attackers will start to place different pieces of their attack into different forensic artifacts to make it harder for defenders to gather all the pieces together. This is actually a sample from a blog post by Dave Kennedy in this link here. So we'll see stuff like this, where PowerShell is just IEXing an environment variable, usually of a random name. And that environment variable is set from a parent process of MSHTA. So MSHTA is the Microsoft HTML application host for Internet Explorer. And when we see stuff like this, typically we'll see MSHTA running with this command line JavaScript. So there's a few things here. Purple is setting a couple strings into variables. And then in yellow, we actually have a path here to a registry key. Now, in that registry key is stored some additional JavaScript code because it's being stored in this blue variable and then being evaled. So what's inside of that? Well, we actually don't know because we don't have that registry key. That sucks, right? But if PowerShell logging was enabled, then we could actually see the PowerShell code that was run because anything that's piped into IEX or an invocation function is logged in ScriptBlock logging. The obfuscated, so MSHTA runs this command line JavaScript. It then pulls this registry key, evals that, which contains a second bunch of likely obfuscated JavaScript. And it can actually go multiple steps. We don't know in this example because we don't have the registry key. But then ultimately, somewhere in that step, that JavaScript will create an environment variable, a process level environment variable called GKWA, and then it will spawn PowerShell to then invoke that. All right, example number 3, PowerShell in your environment. This one's kind of weird, right? Remember before how we saw that attackers, they keep using something as long as it works. But as soon as there becomes a certain detection rate, a certain prevention rate, then they'll change something. And so they'll take something as simple as this to invoke an environment variable and change it into something like this. And just applying some token layer obfuscation to get around basic command line detections. And what we see here is the exact same functionality where this is now your environment variable, and then this is IEX. So let's break this down. When it comes to variables in PowerShell, well-placed tick marks is a nice obfuscator, but we're actually going to remove this to kind of go backwards. So comspec, let's remove the tick marks. Comspec is 27 characters long, and it is the full path to command.exe. But what you'll notice that in this example, it's being treated as an array, and so the 4th, 15th, and 25th characters are I, E, and X. That array is then joined together with no white space, which is the string IEX, and with the dot operator, it is the same as IEX as a commandlet. So that's IEX. Now, for the environment variable, the second piece. This -f format operator is one of my favorite things as an obfuscator and when it comes to evasive tradecraft. So what it means is that all the arrays, all the substrings on the right, are then going to be transposed into the left. So the 0th one in green here will replace curly braces 0, and so forth. So that becomes that. So that's the string environment. And now this is a direct typecast, which is the same as the environment class. And then SV is short for set variable, all right? The second piece we can see here is invoking. This is short for get variable, and VA is short for value only. So this is the same as environment, all right? So let's keep going. We have 2 more strings here that also use this format operator for string reordering. So let's just fix that, get environment variable and process, and then let's clean it up a little bit. Instead of having these parentheses and quotes and .invoke, we'll just move it back so they're actually truly methods, not strings and acting as methods. And now we have environment calling get environment variable of GKWA, the same as the original one, and it's a process level environment variable. So that was fun, right? Now, that really sucks to detect the original command, right? But again, if PowerShell logging is enabled, then you can actually see these layers, and it doesn't really matter how obfuscated the attacker gets. The final code that is invoked by IEX will be visible in what's called the ScriptBlock logs and a couple other places. All right, so those are some of the things that we see in the wild. The next 3 samples we're going to look at, we definitely see in the wild, but it's a bit easier if you want to get your hands on the code because it's all open source out in GitHub. The first one is a tool called Crack Map Exec, written by a guy named Marcelo, and it is a combination of 3 additional tools: CredCrack, SMB Map, and SMB Exec. So when we see this run today, it looks a little bit like this. And now this is using an ASCII encoding from the invoke obfuscation PowerShell obfuscation framework that a colleague of mine ported from PowerShell to Python. And Marcelo loves writing his tools in Python, so he took that port, threw it in his tool, and now it pumps out code like this. So this first part is a very similar way of writing IEX, right? So let's just write IEX there. The rest of the payload is ASCII, is an array of ASCII int values. So we're going to cast that to a char array and then join it as a string with no white space to make it a string, in which we get something like this. Now, the first portion of this try block. This is an AMSI bypass, so the Anti-Malware Scan Interface. There's a few of these floating around. Matt Graver tweeted the first one a couple years ago. And basically what it's trying to do is it's trying to say, for this current PowerShell session, let me disable the visibility that AMSI gives any provider that is interacting with it. So it's going to try to do that first. At the second point, it's going to say, hey, I'm going to be calling, I want you to disregard the SSL cert check for the web request I'm about to make, which is right here. Now this is the guts of this command. So this is downloading from another internal system, invoke Mimikatz, which Mimikatz is one of the most prolific password dumping tools that we see attackers use, written by a Frenchman named Delpy, Benjamin Delpy, also known as Gentle Kiwi. And then the second command actually runs invoke Mimikatz and stores the result in the variable CMD. Now, this is an internal IP. So typically we see attackers running this internally for lateral movement. And what they're doing is they're saying, I'm starting from source A, and they're running this code on a remote system and then getting the credentials back from that system. And typically this is done launched over WMI. So on the target system, you'll see WMI prvse.exe launching this PowerShell command to run this payload. Now the rest of the command is saying, all right, let me take the CMD results in this variable and then post it back to the calling system. And typically when we see this, we'll see attackers maybe do 1 or 2 systems at a time, or they'll just go crazy and hit like 150 systems all at once, all of them posting their creds back. So out of the box, this is actually kind of a noisy a tool if you know what to look for, but anything is easy to find if you know what to look for, right? So people that make modifications to this code can start to really give defenders a hard time if you're trying to detect the very front kind of outer wrapping of obfuscation. But again, if you have PowerShell logging enabled, then all this is being invoked into IEX, and you can see all that in the PowerShell logs. Empire, 2 more samples left. So Empire is written by Will Schroeder, and it's really awesome. It's the first PowerShell kind of full cryptographically secure RAT, or remote access tool. He released it a couple years ago, and we definitely see this one being used quite a bit. Typically, we'll see it launched like this, with an encoded command being launched from malicious documents, HTA files, or just straight over WMI, or installed as a service. So if we decode this, then this is the whole horrendous block of code that we get, all right? So let's clean this up and look a little closer. So we're going to break it up into 2 blocks. The first one says, hey, if you're PowerShell version 3 or later, you're super special because you actually have the ability to do some really insanely cool logging. So let's see if we can take care of that as an attacker to make our footsteps to be a little bit quieter. So if you're version 3 or greater, then we're going to try to disable ScriptBlock logging and ScriptBlock invocation logging, as well as the familiar AMSI bypass. So it's going to try to do all that if you're PowerShell version 3. Now, an important thing to note, even if this bypass is successful, as defenders, we can look for evidence of this bypass being attempted. Again, going to the PowerShell ScriptBlock logging, module logging, and some other sources. So the second piece, after it tries to disable that visibility, is it will go through, it's going to set up at the very beginning, it's going to set up its user agent string, add that to the web client object. It's going to try to use the default web proxy and default credentials of the system. This horrendous dark gray blob here, I've blown up here, which is an RC4 decryption routine, which means that the C2 that is downloading this code is RC4 encrypted. So in this case, it's a local system because it was a lab test. But basically, if as a defender, we catch this command and decode it and then go try to pull this payload, then it's going to be RC4 encrypted. And this blob up here is what's actually decrypting that. And then this is the routine which finally decrypts it and pipes it once again into IEX. So the cool part here is this is a staged payload, which means this is stage number 1, but the full rest of the content is hosted remotely on the C2 server. So what if this runs 20 minutes ago and we catch it and we're super fast and we decode it and look at this and we try to pull down that payload because I have all the keys here, but the payload has been removed. The attacker only allowed it to be downloaded once and then it pulled it from its server. Well, that stinks for us because now we can't get the payload. But once again, if we had PowerShell logging enabled, then anything piped into IEX then we would have seen in our logs. The last one is Cobalt Strike. Now this one is not open source as a closed source commercial red team tool, but we see this used quite a bit by red teams and real world attackers, and so I think it's important to look at. Now typically we'll see something like this for some of the kind of out of the box launchers. You'll notice this ComSpec. This is actually, typically we'll see this launched as a service this way. So services.exe will launch this, and ComSpec is cmd.exe. So the command chain is services.exe, cmd.exe, and then PowerShell.exe. And so when an attacker creates a new service for this, they'll either do that for lateral movement or even locally for a more privileged execution, since the service will run as system. When a service is created, we as defenders should be looking in the system event logs for EID 7045, which is for service creation. However, some really smart attackers will modify existing services, which doesn't produce this event. Also, they might create a new service but make it completely benign and then immediately modify it. So the 7045 is for something benign, and then their malicious activity isn't logged in the 7045. So what we do and what we recommend is that you also monitor the registry itself, looking at services for image path. Another really sneaky thing that we've seen very few attackers do is if you go into services and you can right-click and configure and say, if this fails, then on the first failure, try this. On the second failure, try this. Third failure, try this, et cetera, et cetera. Those are additional subkeys that aren't image path. So it's really important to play around with these artifacts because an attacker could create a service for something completely benign that will purposely fail, and after 30 seconds, it will go and run their code. That's super sneaky, but really cool in my opinion. So let's look at the ComSpec part. Why launch command and then launch PowerShell? Well, typically when services run, it's expecting a service executable to, when it successfully starts, to send a message back and be like, hey, as a service, I'm good, I'm running. You can show a running status in the services. However, this is not a service, and it's never going to send that signal back to say I'm good. So in 30 seconds, services is going to say, hey, this service timed out because it didn't tell me it started, and then it's going to kill the process it started, which in this case, it will kill command.exe, but that's okay because command.exe started PowerShell, and it used the start command to launch as a background process, so PowerShell is still running even though command was started. Now, the first time I saw this being used, in the event logs, it'll say the service wasn't able to start and it failed. And I thought, ha ha ha, silly attackers, their payload didn't work. No, it actually did, but services was doing what it thought was right by saying this payload never told me it was running, so therefore this service didn't start, but it for sure is running, and it's definitely a cause for concern. So if we decode this encoded command, we get a payload like this, which looks similar to one of the first examples that we saw. Massive base64 blob, so let's decode that memory stream, store it into S, gzip decompress, and then that gets fed into IEX where it executes. Now, if we look at what it actually executes, it looks like this. Set strict mode version 2, and then there's this massive here string in this variable by default that's called doit. Inside of that, we have two big functions. This is the majority of the payload. It's very redacted because it's massive. The first two functions are basically setting up the shellcode loader. So it can load the var code variable, base64 encoded shellcode, directly into memory. And then at the very end, we have this if block. Because this is a 32-bit payload, so that int pointer size is basically saying, am I on a 32 or 64-bit system? The else block says, okay, I'm on a 32-bit system, go ahead and invoke the doit contents, which is all the here string. But if it's on a 64-bit system, it will use start job and run as 32 to spawn a child process of PowerShell 32-bit to run that payload. Now, an interesting thing is that let's say that the attacker is running all this from unmanaged PowerShell or from a renamed PowerShell binary. That start job is actually going to spawn a child process of PowerShell.exe no matter the name of the parent process. And so some detections will look for like a sysfile64 PowerShell spawning a system32. Actually, maybe it's vice versa. And also looking for the sysnative environment variable. Those are some of the artifacts of Cobalt Strike on the command line. But again, there's some interesting artifacts behind the scenes that PowerShell's start job creates. So in the defer community and the IR community, we like to make do it jokes, just do it. And there's I had to use that meme, and this seemed like the perfect place to do it. Whew. All right. That was a lot. That was a whirlwind, right? I don't know if you're like me, but when I go to phase, I like to hit everything at once, sit down so I don't have to get up again. So we got a lot of samples out of the way. What about some more forensic artifacts and detection approaches? Well, we covered a lot of these already. So event logs. At the very minimum, we want to have process auditing event logs, whether it's security 4688, sysmon EID1 with parent process arguments enabled, service creation. So looking at the system 7045 event logs, and also all the freaking PowerShell logs, which we're going to look at in just a couple minutes. You want all of those because they're really awesome. looking at and monitoring places in the registry, both for historical analysis as well as real-time going forward. Looking at services, all the subkeys, image path, DLL path, first, second, third error runs. Also run keys, run once keys, other persistence locations like COM startups, all these sorts of things. And honestly, for me, I like to look for PowerShell and any interesting artifacts anywhere in registry. Like what all registry keys have HTTP in them? Just the string HTTP. That might be interesting, and I might be able to whitelist some stuff out and start to find new persistence locations based on looking for known things in unknown places. Other places that we see some nice attackers doing some fun stuff is in the WMI repository, looking at classes, properties, custom classes, and then looking at some of the more elementary things like files getting dropped to startup folders. Now, anyone who's looked at files getting dropped to startup folders know there's a lot of those, and a lot of applications do really weird stuff. So none of this stuff is easy. If it was, then we wouldn't have jobs, because it would just be completely automated and we wouldn't have anything else to look at. But again, there's a lot of places that we can start looking, and there's a lot of great open source resources and information to kind of help guide us to certain, maybe like not higher fidelity, places that is a little more return on investment in the time that we put in. Another thing that we can look at is just parent-child process relationships. So if we get those event logs for process creation, start to look for PowerShell, PWSH, and even PowerShell ISE. If attackers are throwing their malicious code into a profile script and then launching PowerShell ISE, it's going to run that code without having any user interaction. But how often in our environment would we expect to see Office applications launching PowerShell? Or launching command, maybe 10 command executions with PowerShell being somewhere in the child process tree? Or maybe email applications, web browsers. Also monitoring things like your middleware stacks, your web servers, your database processes. How often should those be launching PowerShell in the chain? Now, some ways that attackers will get around this is they will sometimes use WMI to launch something, or use COM to launch something, which kind of breaks that parent-child process relationship, but this is still a really valuable way to catch a lot of low-hanging fruit. In this case, fruit being a tomato thrown in your face by the attackers. And what I mentioned earlier is I like to look for certain PowerShell and other syntax anywhere I can find. I want to search every event log, every registry key, and kind of cast a really wide net to find interesting stuff. And this often is how we find really interesting and novel attacker techniques, is for finding something that we know in a context we've never seen before. URL rules are a really good way as well, scanning on disk. Another place I like to do disk-based kind of content searching is on like download folders, iNet cache, temporary internet files, as well as WebDAV cache folders as well. One other thing is when it comes to network, I'm looking for PowerShell syntax on the network. I also like to look for PowerShell command line arguments on the network, not just the contents of the scripts themselves. And we've seen this happen where attackers will be pushing commands over SMB, or also a really interesting approach is some attackers very cleverly will create scheduled tasks on the remote system by using SMB and pushing over a scheduled task XML file. And there's some interesting forensic benefits for them to do that as opposed to creating a remote scheduled task. All right, PowerShell event logs. So PowerShell, in comparison to other languages, is unmatched when it comes to the visibility that it gives you. It's quite insane, actually. It's so insane that you have to be really careful when you start looking at them, because you can get overwhelmed, because you're not used to this kind of information, right? You're not used to seeing every freaking thing that happens. So don't freak out. And when you talk to the team that maybe manages the retention of all these logs, help them, sit them down and say, hey, here's the benefits from this. And you know what I would say is sometimes you might have to start small. Maybe it means you pull all the logs from a few systems to show the value that's there to convince them this is worth having. Other times, maybe it's just taking one of the logs and starting there and then adding as you go so that you can say, I'm adding these logs because here's the detection wins that we're going to get from it. So the three main categories of PowerShell logging here is module logs, ScriptBlock logs, and transcription logs. So we'll start with the fun one, transcription, or over-the-shoulder logging. Input and output of everything that's happening in PowerShell. Now, this one is not the prettiest format, but it's really cool, and honestly, it's one of the ones that I see the least. But let's take a look at this. It has like a kind of a stepbrother, I would say. This text file called console host history.txt. Now, the first time I saw this was from Matt Graber tweeting this out back in 2016. And so, for example, if an attacker opens up an interactive PowerShell prompt and says get command Yoda and then runs invoke Yoda doesn't exist. And we get that nice red error message there. Well, if we look on disk, that session created a console host history file.txt, and it added those two input commands, just like that. Now, what happens is if an attacker then opens another PowerShell session, it can immediately type the up arrow, and it will read in these commands from this console host history file. If you type get history, they won't show up arrow, they will show up. So this is a really nice way in later versions of PowerShell to say these commands were for sure entered by an interactive PowerShell session. Now, the true transcription logging is not this. It's much better than this because it has a lot more information, and it's not just limited to interactive PowerShell sessions. So when PowerShell starts up, then you have this amazing transcription log with the versions, current user desktop, all this kind of stuff. In addition, transcription logging can be set to be logged to a remote file share, which is really nice because the logs will immediately be off the system that the attacker might be on. So if they want to attack those logs, or if they want to remove those logs, they have to delete all the event logs as well as now get access to this remote system, this remote file share, and delete the logs there. But we'll see it has timestamps for every command, something we didn't have in that text file. And it also has input and output. So it has this full output command here of that error code, which is really nice. Second category is module logging. Now, module logging is freaking verbose. It's really loud because it records everything, and that's really awesome. Especially if you're tracking an attacker and they're doing directory listings, it literally shows you all the output, every single thing that comes out. So it's really, really great. Now, there's two places where you can find these module logs. One is in the original Windows PowerShell event log in EID 800. The other one is in the PowerShell operational event log, EID 4103. Now, it's almost the same data. There's actually a fun little surprise in here. For the newer event log, the error actually says the term /invoke-yoda. Now, there are some really fascinating hijacking opportunities for offensive and even kind of defense when it comes to the way that PowerShell 3 and later does auto module loading, because it actually looks for a name on disk first as a file on disk before it actually does auto module loading the first time to then say, is this actually a module or a commandlet? The last one is ScriptBlock logging. So the first time that we find a payload and it's wrapped in 5 layers of stuff, we get real excited. We start to unwrap it and see the next layer and we think, oh man, I'm so good at decoding, and get to the final layer and you're like, oh, this is bad. That was really fun. However, unwrapping will destroy your soul and you will just have this dead look in your eyes. And all of your colleagues will have this dead look in your eyes. And then they'll look at you and they'll just get really mad and it's, why did you build these tools to let attackers do this stuff so easily? And then I have to decode it. That's pretty much how that plays out. So PowerShell ScriptBlock logging will restore the joy of Christmas to any incident response analyst. So remember, all these samples that we had, every layer, eventually it has to be invoked by IEX or a ScriptBlock creation and invocation, maybe a .invoke method, or some of these crazy ComSpec things that eventually turn into IEX. And when that happens, even if it's from content stored on a remote server that's not even there anymore, at the time in which it was invoked, we'll see it in ScriptBlock logs. So as an example, I threw up on Pastebin this nice invoke Yoda function with this amazing ASCII art. And so if this is what the attacker chooses to use their time to do, if they open up PowerShell, do a little remote download cradle to invoke, and then call that function invoke Yoda, this is the output. And then, if we go into the ScriptBlock logs, it's all there. That remote content, even the beautiful ASCII art sitting right there in ScriptBlock logs, how cool is that? ScriptBlock logs are preserving ASCII art, people. How cool is that? Man, it gets me so jazzed. So, for a demo, just to show how awesome this is when it comes to PowerShell logging. So this is me having some fun with a few of the obfuscation frameworks that I've worked on over the past couple years. You can see my love for colors. I am the biggest right host rule breaker because I love colors. They're so pretty. But sometimes you need output and you don't want it to get into your pipeline, and this is what happens. So please hold your tomatoes until the end. But I have fun, and my wife really likes the colors as well. So if she's happy, I'm happy. So the first one is invoke Cradlecrafter. Just throw in a URL, which is going to be our bit.ly link, which resolves to the Pastebin link. Then we're going to throw in the post command cradle, which is invoke Yoda. Then we're going to get nice options of memory-based download cradles and disk-based. So we'll choose memory. We'll go into the first one and just say, yeah, randomly screw all this stuff up with some substitution obfuscation. Copy that to the clipboard. We're then going to go to the next tool, invoke obfuscation, which will take any arbitrary PowerShell command or script and then allow you to do any number of wrapped obfuscation layers. So we're going to throw that in, go to do some token layer obfuscation. Then we're going to go into encoding. We're going to choose option 2, which is hexadecimal encoding. It's going to think for a second because I'm throwing a lot at it, and that's what we get out. And it's going to be 4,244 characters. So let's copy that to the clipboard, throw it into a new session. It's going to remotely download, execute the function, invoke the function, and then we're going to refresh our PowerShell ScriptBlock logs, and we're going to see Yoda. How cool is that? It doesn't matter how many layers we threw at it, the final payload is there. All right, we're not done yet. So let's remove that log. Let's clear it out. Let's go back to our original cradle crafter command. So we're going to take that first layer of PowerShell obfuscation. And then let's go and throw it into invoked obfuscation. Now this is going to use command.exe's layer of obfuscation as well. So we can start to mix and match these languages and see that it doesn't really phase PowerShell, PowerShell logging. So we're going to set the final binary to PowerShell, which means we're going to wrap command.exe obfuscation around PowerShell and still preserve PowerShell level escaping inside of command level escaping. This was a nightmare to build. That's why I'm showing it so I can get some credit for it. We're going to choose for code in encoding, which is the for loop encoding, which is going to take the full command, push it into a single variable with all the unique characters, and then it's going to create this massive, massive, massive array of all the indexes of those characters. And then command.exe in memory is going to character by character rebuild the payload. And it's using a lot of white space, escape character, as well as some comma and semicolon separator character obfuscation in there. And then if we paste it into a command prompt, the standard output goes through character by character. It's being reassembled in memory. You will not see this command in command prompts process arguments, but where will we see it? Back in the ScriptBlock logging. Let's go through, refresh, scroll down, and there's Yoda. That is amazing to me. That's the joy of Christmas right here, right? That's the fun of unwrapping, is that all this work has been done for us. All we have to do is just turn it on, centralize it, look at it, take advantage of it. So we started with a command like this, with that first layer of obfuscation with our URL and our command, to another one like this with token layer obfuscation, another one like this with that crazy hexadecimal stuff, right? That's crazy. I don't want to have to deal with each of those layers. I want to get to the actual meat underneath. The second one, we started with the initial command and then did that obfuscation stuff. Again, I like detecting this kind of stuff because that means I can find evil before it's ever been executed. But at the end of the day, if I missed it, this is what it's like to find these attackers, right? PowerShell logging, it's awesome. When we do investigations and people have this logging enabled, it's like a dream come true. We almost get overwhelmed ourselves with the amount of data that's there, but man, is it a good feeling. Okay, some novel detection approaches here. A few years ago, Lee Holmes and I became really good friends, and we did this research on using some data science techniques to detect obfuscated PowerShell using the abstract syntax tree. And that was a lot of fun, and here's a GIF of that, and there's some more information about that. But this is basically a signature-less approach to detecting really obfuscated PowerShell content. The next one is PesterSec. I'll be presenting this tomorrow, and this is also using the abstract syntax tree, but it allows you to still use signatures, but to use it very targeted to certain aspects of PowerShell code and scripts, and it's really a lot of fun to kind of merge the best of both worlds in terms of signatures, but being able to really parse the PowerShell syntax out, and it's a lot of fun. And this was something I started kind of in response to this guy named Ryan Cobb, who after revoke obfuscation came up with a way to minimally obfuscate PowerShell, to obfuscate it just enough to evade signatures, but not enough to make it look suspicious to the data science approach of revoke obfuscation. Another thing that we can do is fingerprinting abnormal scripts by commandlet grouping. Now, I've not seen anyone talk about this before, and it's actually kind of a fun mental exercise. But basically, if we have extracted scripts, we can use the abstract syntax tree to pull all the commandlets and group, or if something has been executed, then we can pull the module logs either in EID 800 or EID 4103 and group on the pipeline ID and command name to say per script, what kind of commandlets do you have? So for example, if we pull down invoke mimikatz from GitHub, and then we tokenize it, and then we group on commands, we get something like this. The most prevalent commandlet is outnull, over 200 of them. Now this is something that the attacker could easily change, because because you can see all these examples of outnull here when they're doing all these defined literals. Well, instead of pipe outnull, they could just start each line with $null equals, right? So we want to make sure that we're looking at the right kinds of commandlets. But even if we say, okay, forget about outnull, how many scripts in our environment should have 95 add member functions? That's really fascinating to me, right? Or maybe more than this many functions, right? And so this is maybe a way that we could start to fingerprint and say, any of these ranges are abnormal in my environment. Therefore, no matter the rest of the content, I'm interested in looking a little closer. This is something that I came across this about 2.5 years ago, and this is the first time that I'm sharing it publicly. And it's really cool to me because it's actually one aspect of the older PowerShell event log that, in my opinion, is a little bit better than the newer one for one very obscure reason. So when it comes to EID 800, For every commandlet that's invoked, in this case, invoke expression, we have not only the commandlet invocation itself, but then we also have the command line from which it came from. The next example, we have IEX, right? So IEX is what we see in the command line, but the commandlet that's being run is still the full name of invoke expression. Now here's where it gets interesting. What if we started to parse these logs and look for every command invocation and said, I want to make sure that your full name or any of your aliases are actually found in the code that you came from? Because now, what if an attacker, instead of IEX, puts a tick mark there? IEX is an alias of invoke expression, so we see invoke expression ran, but nowhere in the command line do we see invoke expression or any of its aliases IEX. So we just found obfuscation just by doing a diff between these two fields that happen to conveniently be in the same event log. Now, there are opportunities for errors here if you have certain content being invoked remotely. But again, we can start to say this commandlet ran, and I don't find it or any of its aliases found in the code block from which it came. Here's another one where if we have that crazy comspec IEX stuff. Again, ultimately, somewhere in this code, it's running invoke expression, but yet we don't see invoke expression anywhere in here, nor any of its legitimate aliases. So finally, key takeaways. PowerShell is powerful. I mean, how else can you explain a community like this coming together to talk about all these different aspects of it? And security is just one aspect of it. It happens to be what I'm super, super passionate about. But the fact is, how cool is it that I get to be a small part of a community of developers and administrators and cloud gurus to be able to use this as not only a scripting language, but really a platform for improving people's lives, for automating stuff, and it's just really, really fun. Attackers also love PowerShell, and it is true. They are using it, and they're doing some really neat stuff with it. But what I would advise you is that when you see these reports about crazy increases in PowerShell used in attacks, like take it with a grain of salt. And again, how many of those are those silly downloaders where PowerShell's downloading an executable and then running in your environment? Offensive PowerShell tradecraft is diverse. And even though we see a lot of reuse for off-the-shelf offensive tools, there are some attack groups that really do some insanely interesting stuff with PowerShell. And you can also kind of get an idea of what other languages they programmed in before, looking at the ways they write in PowerShell code, which is kind of cool. And you kind of get to feel like you're learning the person behind the keyboard as you see their payload and their tradecraft evolve over time. And finally, there's a plethora of forensic artifacts and detection approaches when it comes to PowerShell, both within the Windows operating system itself, as well as the incredible module, ScriptBlock, and transcription logging within PowerShell. And in this talk, I didn't even touch any of the preventative measures that PowerShell also introduces. And Lee Holmes has done some really great talks on that as well. So if you haven't seen that, I'd recommend checking it out. And again, that earlier PowerShell Hearts of the Blue Team is a great resource for that stuff as well. And lastly, when you have this PowerShell logging enabled, man, the visibility is insane. It really is. There's nothing quite like it. So if you don't have it in your environment, then I encourage you, I implore you to turn it on, because you will be very happy that you have it when that day comes when you really need it. So with that, I really appreciate your time. We have a couple minutes for questions, but if you want to ask your question later and not in front of the whole group, then I'm around. Please just grab me. This has been a lot of fun. So again, I really appreciate your time. And I've been told I should end on this slide. So I'm not a rule breaker. So thank you. So there's 7 minutes before the next person comes on stage. Are there any questions or tomatoes? Yes. So from an obfuscation perspective, you mean? The benefit is that I thought it would be fun when I wrote the frameworks to do that, because it meant I had a detection opportunity. Because while that's kind of the sneaky answer. And also because maybe there's someone out there that was doing like case-specific matching, and I wanted to show that we shouldn't do that. We should do case-insensitive where possible. But yeah, that's the short answer. Wherever I could do it, then that's the way I implemented it. So great question. Yes. So the question is there a comparable logging on core in Linux? I do not know. Yeah. Is there? Yeah. Okay, like all three modules, ScriptBlock and transcription? Okay, thank you. So it sounds like transcription logging is there for PowerShell core. This is awesome. I'm learning so much. For the video, the first question was about casing. Is there like a reason for the randomized casing in the obfuscation stuff? So there's a question in the back. Ah, yes, excellent question. I can't believe I didn't put a slide in there for that. Yes. So the question is version downgrade still a way to get around this logging? And the answer is absolutely yes. So if you follow all these rules and you get later versions of PowerShell, let's say PowerShell 5, enable all this logging, if you still have Windows Management Framework 3.5, if you still have PowerShell 2 on the system, an attacker can just downgrade attack, which means they just force the PowerShell session to use that lower version, which doesn't have any of the core visibility later. So definitely remove the older version once you get the newer version. So excellent question. I definitely should have had a slide for that. So I also don't know. So the question was, do serverless functions capture all this visibility with these different loggings? I'm seeing some no's, I'm seeing some shaking heads. I don't know. That's a great question. Yeah, I don't know. I'd be interested in the answer, though. I just haven't played around with serverless much in this world. So it's funny because attackers always use like the simplest components of PowerShell because they want their tradecraft to work anywhere where they land. So I find, so in the security world, whether you're offense or defense, you find yourselves only working with like the really old stuff because it works everywhere. So we're kind of in this like, kind of have blinders on in terms of all the other possibilities of PowerShell, which is kind of a disadvantage. Yeah, so the question was, do we run into really, really targeted examples with PowerShell where they know maybe a lot of information about the system they're going to hit? We definitely do. Typically, we'll see that when what we call guardrailing and environment keying is in place. So maybe the key, maybe they have their payload encrypted, and the only key that will decrypt it is nowhere to be found in the code, but it's maybe the name of the domain of the system that it's going to land on. In that case, let's say if defenders get it, if someone uploads it to VirusTotal and we download it, or if a sandbox gets it, if they don't have the domain that it came from, then they don't know, then they can't run it. So that's some examples of like guardrailing. Some red teams will also do that, just to make sure that, hey, Bank A has hired us to do this red team, this penetration test. I realize those are two different things, and I'll get booed by red teamers for saying that in the same sentence. But an offensive engagement, right? Then we want our payloads to only run on that bank's domain. So if we key our payloads to only run on that domain, then that doesn't mean we're necessarily being mean to the defenders of other places. It means that if someone accidentally emails that phish to their cousin and their cousin opens it, it's not going to run on their computer because their computer's domain doesn't match the one it's keyed for. So those are some of the examples of really targeted attacks where the attacker knows a lot about their environment. And a lot of times they'll do that with a really simple initial phish, where the first phish doesn't do anything malicious other than gather information about the computer, post it back up, and then they key their next payloads off of that. So excellent question. Excellent. Oh man, what do I tell my colleagues? Well, that assumes my colleagues are saying that, right? So, or people in the industry, yeah. What do I tell people? What do I tell people who advise clients to get rid of PowerShell? Oh man, I shake my head. Yeah, I shake my head, and it's kind of throwing the baby out with the bathwater. Now, here's the deal: if you're a company of 50 people and no one today uses PowerShell, then sure, you could try to do that, but most people just delete PowerShell.exe and think they're solving the problem, and they don't realize kind of how deep PowerShell goes. So at the end of the day, a client hires us to give them our opinion, and we don't have a say in what they do. And so we definitely do have some clients that decide this is still the best way they want to try to remove PowerShell. Typically, they're repeat clients because they didn't do it as well as they thought they did, and they get popped. But yeah, my recommendation is not to remove it, but it's to lock it down with all the features that have been given for us to lock it down. Yeah, excellent question. One more. All right, well, I'm at time. Thank you again. Those are some awesome questions. I have some homework to do on serverless, but thank you again.